Hey everyone, here's a short screencast that'll walk us through how to build a simulation for this situation from the AP exam 2009B number 3. So again, this is going to be a challenging because there are two different groups. There are 754 people who are treated with a cardio pump. 37 of them survived. And there are 746 patients who were treated with CPR, and 15 of them actually survived, at least a year. So is there evidence that the proportion of people who survived at least a year with the cardio pump, is that proportion higher than the CPR group? So it seems like what we have here is we have 1,500 total people involved in the study, and of them, 52 of them seem to live for or survive for at least a year. What we're going to do is we're going to randomly sort out the 1,500 people into the two groups, one of 754 and one of 746, and we're going to see if we come up with something as extreme as 37 survived and 15 survived in the two groups. So let's go to GeoGebra for a moment. And what we'll do is this: we're going to create a set. We'll use ones to represent the cancer patients, or not the cancer patients, excuse me, the people who survived for at least a year. So survived equals, and there are 52 of them, so I'll use a sequence command, and I want to use a 1 to represent them, and then I'll use a dummy variable 1 to 52, and then the others will be a sequence command, and those will just be zeros, and I'll use a dummy variable, and I'll go from 1 to 1,448. And then what I'm going to do is I'm going to take my total amount, total people. I'm going to join the survive list and the others list in one big super list. And then I'm going to shuffle, I'll call it shufftote. I'm going to shuffle this list. And so you can see what happens. So there's some zeros and ones, zeros and ones, zeros and ones. So what I'm going to do then is I'm going to take the first 754 out of that list, and I'll call that the cardio pump. So I will call that the pump. And I'm going to take from the shuffle total, I'm going to take from position 1 to position 754. And then the CPR will be the ref. So I will take from the shuff total list, I will go from position 755 to the end, which is 1,500. And so what I'm interested in is I'm interested in what proportion in the pump group lived or survived at least a year. So what I'm going to do is I'm going to call this pump proportion equals, I'm going to add up the sum of the pump list, because those will give me how many there were, and I'm going to divide that by 754. So that's the proportion in the pump list, and I'll go CPR prop, and I'm going to do the sum of the CPR list, and then likewise I'm going to divide that by 746. So you can see the difference, and I want to know if the pump proportion is much larger than the CPR proportion. So I'll have my differences be the pump prop minus the CPR prop. And of course, by rounding, that difference is 0. And then what I would like to do is I would like to run a simulation where I take this number and put it into some empty set that I've created. So as I run the simulation, I'm going to shuffle all these numbers and all these sets here. I'm going to do this computation. I'm going to compute a difference, and I'm going to stick it in this empty set. And I'm going to do that 100 times. And I want to see how often we see a difference as extreme or as large as ours was. So what I'm going to do is I'm going to create a button, and I'll click that button down here at the bottom, and that will be a randomize. And then in the script, I'm going to repeat 100 times. Actually, I'll probably do it 10 times and just click on the button a couple of times to make it easier. I will repeat 10 times. I'm going to update the construction. And then what I'm going to do in the data command, or the data button, I'll go to the object properties, and every time it's updated in the script, I want to set the value of the data set, which is what I'm working in, to be the data set appended with the variable diff. Click OK, and then I'll close that window out. And then so what's going to happen when I click on this, there's my data set right there. And I think what we could probably do, we could probably change our rounding a little bit. So if I go to rounding, and maybe I'll make it to 5 decimal places. Yeah, there we go. We can see some differences there. And let's create a dot plot. And so I'm going to use the data list. And I do not want to stack numbers close to each other together. And I'm going to make my scale factor to be 0.2. That seems to work out pretty well. And I'm going to, let's kind of drag my scale out a little bit. Again, I don't need to be that wide. I have a feeling that my these numbers are all going to be reasonably close to 0. And so every time I click on re-randomize, it's adding 10 to the set. I'm going to hide the label as well. And so that's 20. And then there's 30 times. And then there's 40 times. And then there's 50 times. Now our original test statistic, we had 37 out of 754, and then we had 15 out of 746 in the other group. So that made for a value of 0.02896. So I'm wondering is how many of those are actually larger than that. So I'm going to go count if x is greater than or equal, if x is greater than or equal to a, and the list I want to use is my data list, and that's going to keep count of how many are actually greater than this number. So as I re-randomize, should add 10 more here in a second. There's a lot of numbers. When you have 1,500 numbers, it takes a while. And again, I'm looking at this number here. I'm wanting to see if that ever changes, because I believe that's the 5th time we've hit this. And there's the 6th time we've hit this. And I believe that's 7, and we haven't seen any as extreme as the ones we've had. So I think that might suggest that perhaps the cardio pump does seem to work a little bit better. So there is that simulation and how to build it. I hope this has been helpful.